Good morning, everybody. I hope everybody's having a fine and pleasant day. Today, what we're going to do is we're going to start our first unit in physics, reminding you that physics is the study of the universe using mathematics, the study of everything. It's that simple of a definition. The math doesn't have to be intimidating. We're going to be fine. So, anyway, this is the presentation. It's in Smart Notebook. That's the title page, and here is the table of contents page. Each bullet represents pretty much a lesson in the unit. Okay, and we're going to start out with what's called motion in one dimension. Okay, but before we really talk about motion in one dimension, we need to define a couple items. The first one is going to be distance. Okay, so if we think about what distance is, distance. In my definition would be how far between 2 points or how long an object is. Those are terms that we could use to describe distance. In a car, if we skip forward, oops, pardon me. In a car, we can measure distances that are elapsed with an odometer right here, and that ticks through distance as the wheels spin. It makes this computer, it's a mechanical computer, move forward. Distances in physics are going to be measured in the unit called the meter right there. You've heard it when we look at really small measurements, it'll be like millimeters. A little bit bigger is centimeters, but a meter pretty much is almost about it's similar to a yard. It's a couple inches longer than a yard. Okay. A meter is the SI unit for distance. That's the most important thing to remember today. Okay, so whenever we use distance in an equation in physics, it's going to be represented with letter D. So distance is D. And when we measure distances, they're going to be measured in the unit meter, which is represented by the symbol M. So distances D are measured in meters M. Okay, the next thing we should talk about will be time. Time is the length of the interval between events, is how I define it, or how much. It's hard to define without using time. Time is we measure how long it takes for something to happen. That's a good way to think about it. Okay, time is like and distance are both hard to define because they're fundamental uh, things in nature that just are what they are. So when we talk about measuring time, and whoops, that was a mistake. We talk about measuring time in an equation. When we use time in an equation, time is going to be represented by the letter t, lowercase t. Whenever we measure time, time will be measured in seconds, which is going to be s. So good measurement of time will be t equals 10s, which is time equals 10 seconds. Okay, let's continue to move forward here. Okay, great. So our next thing that we want to talk about is going to be putting distance and time together in our first true physics equation, and we're going to define the concept of speed. Speed is defined as the distance that we cover divided by the time it takes to cover that. So speed is equal to distance divided by time. In an equation, speed is represented by s will equal d, which is distance over t, which is time. Okay, so speed is, I like to think about distance as how far, time is how long it takes, and speed, I like to think of that as how fast. Okay, I'm waiting for my button to push here. Whoops, too many, too fast there. Okay, so if we look at the equation, when we look at the equation for speed, speed is equal to distance over time, because distance is measured in meters and time is measured in seconds. The unit for measuring speed, is going to be meters per second. You can think about it like in your car, it will be miles per hour. But being that we're dealing with science and we're using metric, or what we refer to as the International System of Measurement, we're going to see that distance will be measured in meters, time in seconds. So we have meters per second, which is abbreviated M divided by S. So moving forward, if we look at the next slide, it lags. There we go. And we take a look at the next slide here. We can see that a car is traveling at 10 meters per second at a constant speed. What does constant mean? Constant mean it stays the same. Does this mean that it increases the speed by 10 meters every second? Does it decrease its speed by 10 meters every second? Does it move with an acceleration of 10 meters per second? Or does it move 10 meters every second? So we already know that the speed is constant. So it's not going to be increasing its speed, so that's wrong. It's not going to, if the speed is constant, it's not going to be decreasing the speed. B is wrong. Man, what's that term? Acceleration. We haven't even looked at that. Accelerate. I think that means goes faster. That would mean not constant speed. That's wrong too. So if we take a look and we want to look at the correct answer will be D. It moves 10 meters every second. So if the car is traveling at a constant speed of 10 meters per second, that means that the car moves 10 meters every second. All right, it's lagging here again. Okay, which leads us to our first problem here. We're going to go ahead and pause for a second. Okay, so in our first slide that we see here with the word problem, we see that a rabbit is going to run a distance of 60 meters in 20 seconds. What's the speed of the rabbit? Okay, the recommended way to do the problems is you're going to identify all the variables. So you're going to write D, T, and S for each word problem. Okay, and then we go in and we read the problem. We identify the distance. In this case, it's 60 meters, which is the distance. The time is going to be 20 seconds. We're looking for the speed. That's a question mark. Speed is question mark. The distance that we are given is 60 meters. Remember, M is the symbol for meters. Time is 20 seconds. S is that. Then next step is I write my equation. Speed equals distance over time. So that's going to be, now I'm going to do the work. I'm going to show my work. So it's going to be 60 meters, which is the distance, divided by the time, which is given as 20 seconds. I do the math. If I do the math there, we're going to say that that will equal 3 meters per second. Our next problem says that an airplane is on a runway, can cover a distance of 500 meters in a time of 10 seconds. We want to know what's the speed. So we have distance, time, speed. The distance is equal to 500 meters. The time is equal to 10 seconds. We're looking for the speed. Speed equals distance over time. which is equal to 500 meters over 10 seconds, which is equal to 50 meters per second. Our next problem is going to be where a car travels at a speed. The speed is already given as 40 meters per second for a time of 4 seconds. And what we want to know now is, that's a question mark, is what's the distance? So we write distance, time, and speed over here. Okay, so the distance is what we're looking for. We know the speed is equal to 40 meters per second. Time is equal to 4 seconds. Now we're going to get a new equation right now. The distance that we move is equal to the velocity times the time. That's the new equation. So the distance that it goes is equal to the velocity that it travels at, 40 meters per second, multiplied by, whoops, that's a parentheses, 4 seconds. That'll equal 160. Now, I have meters per second and seconds there. It's important to know that we're solving for distance. So distances are always going to be measured in meters. You're just going to have to sort of remember that in this case. Our next problem that we only have a couple more minutes. We have a practice of a distance is equal to velocity times time problem right now. So next one we know the speed again. We know the time again. We're looking for the distance. Distance, speed, time. And it doesn't matter what order you put them in. So the speed is 20 meters per second. The time is equal to 6 seconds. We're looking for distance. Distance, like we just said in the previous problem, is equal to the velocity or speed. Speed times time. We should write S, speed times time. So the speed is 20 times the time, which is 6, I'm sorry. That's 120. Remember, distances are measured in meters. So distance is equal to 120 meters. We have about 2 minutes for 2 problems right here. So let me go ahead and do the next problem for you. It's going to be a new type of problem. In this problem, I'm sure that we're going to be looking for time. Okay, now we travel at a constant speed of 20 meters per second. How much time, that's a question mark, does it take to cover a distance of 120 meters? So let's identify distance, time, and speed. The distance we go is 120 meters. The time is what we're looking for. The speed is equal to 20 meters per second. Time will be calculated by doing distance over speed, which is equal to 120 meters over 20 meters per second. So 120 divided by 20 is going to be equal to 6. So how do we measure time? We have meters and meters per second. It's easy just to remember the time is measured in seconds. Okay, I have one more problem. No, I think that's the last type of problem. That's my last slide. I only have about 30 seconds left anyway. So what's important to remember when we do this work, let's try and get this new slide created real fast here. It's going to happen, just lagging. Okay, it's important to remember that distance is measured in meters, m. Time is measured in seconds, which is s. Speed is measured in meters per second, which is m divided by s. That's a parentheses.